Welcome to Intro to Technology. I am Professor Kari Iowanu, and I will be teaching this class. My office at the school is in room T136, and my telephone number is 914-606-8561. Since we are not at the college at this point, the best way to get a hold of me is through my email, which is at kiriakos.iowanu@sunywcc.edu. I will get to my email very quickly and definitely within 48 hours. This class is organized a little differently than it used to be. This class is now a project-based class, so instead of a textbook, you'll be required to purchase an Arduino kit. You will also need to install the Arduino IDE on your laptop, and that is so that you can then take the programming and program the Arduino with it. The projects will be presented and recorded, and then they will be in different technology disciplines and will include a photonics component. You will also be required to have a Tinkercad account. This is a free account. It's actually, I guess, owned by Autodesk, and this will be very helpful in modeling your projects on the computer, and it will also help you guys in programming the Arduino, since once you set it up on the Tinkercad, it actually has an option to export the code. I have the links here for the Tinkercad software and for the Arduino software, as well as for the kit that I am asking you guys to buy. This link is to purchase the kit on Amazon, but it is also available at the college bookstore. So at Westchester Community College, we have 3 different technology programs. We have mechanical technology, which includes photonics and also includes the CAD certificate. We have our civil technology program, and we have our electrical technology program. And under the electrical technology program, we also offer a degree in energy systems. So what is mechanical technology? Mechanical technology is a field that deals with the design of products and systems, the fabrication and production of machinery and products, and also the repair, rebuilding, and testing of systems. So I used that word systems in the previous slide, but what is a system? And as we look at it, a system is a number of components designed to work together to accomplish something. So an example is a heating, ventilation, and air conditioning system. In a typical house, that consists of several components that will work together to get you heat or air conditioning. So as an example, in my house, I have hot air heat, and I have air conditioning built into that. There is a thermostat that measures the temperature in a room, and if the temperature falls below a certain temperature while in heating mode, it sends a signal that we need heat. My system is slightly different, but I have a geothermal system, but I'll explain how it works. What happens with that is I have a tank that is storing hot water when it's in heating mode, and that's bringing the water up from underground and heating it up to about 115 degrees in my system. So when my system calls for heat, that water runs through a set of coils, and there's a fan that blows over that and pushes the hot air through a series of ducts that goes into the house. And there the house is heated. So the thing with a system is that it has to be designed to work together, because if one part of it fails, the whole system could fail, right? So other examples of systems, and I have fluid systems here, I have hydraulic systems, plumbing systems, utility transmission systems. I worked early in my career in natural gas distribution, and that is a fluid. So we would get it from a pipeline at a very high pressure, and then we would reduce the pressure at a pressure reducing station, that would then go through the system. But then before it got to people's houses, the pressure was reduced one more time to deliver it at the pressure that was appropriate for the house. An example of a hydraulic system, something that we may all be familiar with, is your car's brakes. So, my car has hydraulic brakes. Most of the cars have hydraulic brakes. And when you step on the brake pedal, you push a rod through the master cylinder, which forces fluid through the brake lines to each individual wheel where there are other cylinders there, and they force the brake pads to close against your brake disc. So, and if, like I said before, if any part of that system fails, the system will fail. And if anybody has had a brake failure, they know it is not fun when that happens. So, and yes, I had it happen on my car where the master cylinder failed and I lost my brakes. Not a fun day. I'm going to talk a little about our photonics, and I'm going to talk about PALTech. And PALTech is it stands for Photonics and Laser Technical Education Center. It's funded by NSF grant 1700564, and that grant was given to the college to establish a photonics concentration, which is under our mechanical technology degree. The reason that we applied for the grant was to train students to work in this high-tech and high-demand field. It will open doors to great careers. The average starting salary with an associate's degree is over $47,000. And there's quite a high demand right now that's expected, over 4,000 jobs in the next 5 years. So what is photonics? Photonics is the science of light and photon generation, detection, and manipulation. It's used in almost every field. I'm going to put these links in Blackboard so that you guys could look at them on your own and see what I have here embedded, because it doesn't work properly when I try to do it now. So what is our curriculum? So this class was actually the first class that was modified for the photonics. So the Intro to Tech was modified and went from a class where you just had professors lecturing to you to a class where we have a combination of lectures and projects. And it's been offered since the fall of 2018 in the modified version. We also modified college algebra with trig, which has since been eliminated, and our tech physics class. The new classes, and it says planned offering fall 2019. I did offer the fundamentals of light and lasers in the fall of 2019. It was offered again this fall, but it was canceled due to lack of enrollment. And the laser and laser systems class is ready to be offered, but I cannot offer that remote because of the laser equipment that's needed to run that class. So where are lasers used? So I list a bunch of stuff here, starting with CDs, DVDs, and Blu-rays. Those are now, I guess, technologies that are on their way out. But the way they operate is they take a laser beam and they basically bounce it off of a disc, a polished disc, where there's actually markings under the disc which are represent zeros and ones because it's digital information, and I could store either data or music or videos on those discs. So without a laser, those would not be possible. Fiber optics and data transmission, I'll put that kind of together because the picture in the middle of the screen is basically a fiber optic cable, and basically a fiber optic allows laser light to be shined through it, and it transmits data or other information, actually, or any information. And some of you may actually have those running to your house. A system like Verizon's Fios is actually using fiber optics to get data to your house. Lasers are used in medicine. On the top of picture it's showing a laser beam hitting an eye and reshaping the eye, and that is how LASIK is done. So yes, lasers are used in medicine. Cell phones, my cell phone actually uses a laser to focus the camera. Construction, they are all sorts of laser levels and the like that are there in the construction field, used on a daily basis. But also, laser measurements are a big thing now. And also, everyone probably is wondering about when we're going to have real self-driving cars. And a lot of the technology behind that actually relies on lasers and then holograms. So anywhere around you, there are lasers. So what does a laser stand for? It actually stands for light amplification by stimulated emission of radiation. How does it work? So the way it works, and this is a picture of a gas laser. And basically, it has two mirrored surfaces. The back surface is a 100% mirror. The front surface is about a 90% mirror. And then there's a flash tube. And what it does is it flashes and it excites the gas that's in the laser. And as it gets excited, the electrons move to a higher energy state. When they drop from the higher state to the lower state, that is when light is emitted. And it bounces back and forth until we have enough laser light that it starts to come out of the laser. So again, like I said, it's like it basically has the mirrors. It's absorbed from the flash tube. It's absorbed onto by the electrons, and when they return to the normal state, they emit the light. So how does laser light differ from regular light? Well, laser light, the big thing is that it is coherent and it is of one wavelength. So on the top figure, you see coherent light where all of the waves are lined up perfectly, right? And the other thing is it's of one wavelength, so it is a pure single color. Visible light contains multiple wavelengths and it is not coherent. So it's not just exactly one color, it's kind of a mixture of colors. So like an example actually is white light is actually white because it has all colors in it, right? And so that's a big difference between the laser light and the incandescent lights and other coherent light sources. So I mentioned self-driving cars, and the way self-driving cars do imaging is they look at they use something called LiDAR, and that stands for light detection and ranging. And what that does is it uses infrared lasers that are rotating at a high speed to measure distances and create 3D images. And that allows the car to know what's in front of it and actually steer around it, stay in their lane, avoid something that is in there. Under the mechanical department, we also have our CAD program, and CAD uses computers to design and draw machinery and equipment, perform 3D modeling, print parts in 3D, control manufacturing processes, model machinery prior to manufacture, model fluid systems, model structural systems. Very important for any technician or engineer right now is to know how to use CAD, and it actually started off, CAD stands for computer-aided drafting. When I started working as an engineer, the CAD programs that were available were generally two-dimensional. But now we have three-dimensional modeling that we could do, and it has really made things wonderful in trying to design something. It's a lot easier to do that now than it was in the old days. So I include this as mechanical technology through the ages because I find this is one of the most fascinating artifacts that has ever been found. It's called the Antikythera mechanism. It dates back to the 1st century BC, And there's been a lot of studying of this object, and what they found it actually is probably the world's first computer, or the first computer that we know. And it was used basically to, it could tell you the position of the planets, the moon, and when there was going to be an eclipse. So very, very advanced technology, considering it was 2,100 years old. Now, unlike computers now, which are digital and work on electricity, you could see from this picture that it's basically a series of gears, but very, very advanced and amazing technology for its time. So civil technology, it's a field that deals with roads, water supply, drainage, sewers, structures, buildings, environmental issues, and pretty much anything that's in the public domain. But in our school, some of our civil technology students actually continue to different fields of engineering or related to construction. So a lot of our students continue and they study architecture, others study project management, and others study environmental engineering. And all of those fields are related to the civil field. So I like to joke around about this poster. This poster is actually available at the United States Geographic Systems website. And I say, go there and download it and print it out and hang it up in your bedroom. But this is actually the water cycle. And what we see in this is that I'm going to start with the ocean, and water is stored in the ocean. Excuse me. And the water will evaporate when the sun hits it, and it condenses in the sky to form the clouds. And the water is stored in the sky in the form of clouds. And then when there's enough humidity in there, enough water, precipitation happens. Depending on the temperature, it's either going to be rain or snow or sleet or hail. And that is stored in ice and snow, and eventually that melts, and it goes down into either freshwater storage or surface runoff, or groundwater, which is underground, and it's stored underground, and it eventually gets its way back into the oceans. So by looking at this wonderful cycle, you see why water is really, really important that we don't pollute it. Because as we go through that cycle, if we polluted it at any one point, it's going to get polluted throughout that whole cycle. Electrical technology deals with all machines, tools, devices, and systems in which a current or flow of electrons take place through conductors and metals. It involves the design and development of high voltage systems and components such as motors, generators, heaters, electrical power transmission and distribution systems, radio wave and optical systems, converters and control systems for operating light and heavy machinery. So you can see there's a lot of stuff that falls under the electrical, especially in what we're doing today. Pretty much everything we do has an electrical component to it. So almost all modern technology, again, includes some form of electrical or electronic technology. And then we have our energy systems program. It's a degree under our electrical technology department that focuses on energy topics, including photovoltaic, wind, lighting, and lighting controls. And we also had a nuclear component, but Indian Point will be shutting down, so I don't know if anybody wants to follow up on that. Control systems. So almost all new technology incorporated some sort of embedded control. The average car now has between 30 and 100 computers and as much as 100 million lines of code. Almost every household appliance has some sort of embedded control in it. Now, I mentioned this in my introduction on the discussion board. I have degrees in mechanical engineering and also computer engineering. And the reason that I went back to get my master's in computer engineering was that I was involved at the time in controlling pump stations that were very large pump stations. And I saw at the time that computers were needed to control all of these things. Excuse me. So you guys, I say every household, I would venture to guess that there are some of you that have something like a Nest thermostat, right, which has an embedded control in it, and it allows you to control your thermostat from anywhere you have an internet connection. So you don't have to be home and control your thermostat. Similarly, embedded controls in something like a Ring doorbell. You know, the Ring doorbell, my son has one, and when they were away and they were actually down in Brazil, they knew who was ringing their doorbell. So, you know, like I said, almost every household now, every household appliance has some sort of embedded control. You know, everything from your microwave, your oven, even if they're not communicating on the internet, they do have an embedded control. Similarly, I do not have it hooked up right now, but my geothermal system actually has output that it will tell you what's going on the internet. Like I said, I do not have it hooked up, but I could if I wanted to. So I found this slide a few years back, and it's kind of changed a little bit. And this slide was done in 2013, but I find it amazing how far we've gone, because they actually will state that everything in a 1991 Radio Shack ad can be replaced by an iPhone, and at this point, any smartphone. And I will even say that a present day smartphone is more powerful than the computer that is listed in there for $1,600. You know, it's better than that camcorder that is listed on the bottom for $800 for $799 there. You know, and you could store all your music, you could communicate, you could do all of that. And none of this would be possible without our electrical technology that we have. And I will also go further and say we offer a class at Westchester Community College in nanotechnology, and none of this would be possible without nanotechnology. So I mentioned earlier that you are going to have to purchase an Arduino. So what is an Arduino? An Arduino is a computer on a card. It can be programmed to perform any number of functions depending on the sensors and devices connected. It can control mechanical, civil, and electrical devices. I have the kit, a link to the kit that I'm asking you to buy, but that's basically what it looks like, that little card. And then you'll program it to do various things, and you'll add things to it so that it will control them. Excuse me. So there will be projects in the disciplines that are offered. Photonics will be incorporated into at least one of the projects, and the projects will be presented, recorded, and submitted on Blackboard. Since you guys are on your own, you'll have to figure out a way to record yourselves and do that. I used to do these projects as group projects, but since we are all remote, I really can't. But if you guys want to figure out a way to work with someone else and do them together, you're welcome to do that also. That is the end of this presentation. I hope you all enjoy the course. I will be posting work on Blackboard. Please keep up with the work, and I will see you guys later.